telescope controlling Greenbelt, we have been given the go-ahead to begin commanding release of the forward latches, which hold the solar arrays in place during launch along the side of the telescope. The forward latches are on both sides, both the port and starboard side of the telescope are released simultaneously.
And so to me, my favorite discovery has been to be able to look out into space and thereby look back into time and see how galaxies appeared at different distances in the universe and therefore at different times in the universe. The speed of light is finite, so it can travel 1 light year per year. So if we look at a galaxy that is 5 billion light years away, we're seeing that galaxy as it was 5 billion years ago. And galaxies develop on billion-year timescales, so we're actually seeing a galaxy as it was, say, when if it's fully formed now, maybe we can see the galaxy when it was a teenager, or maybe when it was a grade schooler. We're trying to push back to see galaxies when they're in kindergarten or even as toddlers. So the ability to see galaxies at different distances and different times, and to visibly watch the development of galaxies over time, that to me is the coolest thing that we've discovered in the last 20 years. By being above Earth's atmosphere, it has finer resolution than any optical comparable telescope can get from the ground. So by having the finest resolution in visible light, we see more details in objects, and we can see smaller objects than we otherwise would. So this helps us in quite a number of places. I'll just give you a couple examples. Let's start with the distant galaxies in the universe. So Hubble has revolutionized the study of distant galaxies in the universe because from the ground, these very distant galaxies are very small and they are blurred out by Earth's atmosphere. So the motions and density changes in Earth's atmosphere blur out the light from these very distant galaxies. We can't see them clearly, and Hubble can actually not only see the larger ones clearly, but actually can see smaller ones that the ground-based telescopes cannot see. So we can makes a census of the distant universe that heretofore had not been possible. The Hubble observations into the infrared. Basically, JADOS-T is an infrared telescope with the resolution that Hubble has. The Spitzer Space Telescope is our current infrared observatory, but it has a very small mirror, and its resolution is, is not comparable to Hubble's. Hubble's is much better than Spitzer. JADOS-T will have comparable resolution, in some cases even better resolution than Hubble, while looking in the infrared. And this will help us because it addresses several of the important unsolved problems in astronomy can only be solved by looking into the infrared. I mentioned that we look at these distant galaxies and we learn about the development of galaxies. Well, due to cosmological redshift, the light from these distant galaxies is shifted toward the red end of the spectrum and even into the infrared. Hubble can see a bit of the near-infrared, but it can't see the mid-infrared. And JADOS-T will have Hubble-like resolution in the mid-infrared and will be able to study these distant galaxies much better than Hubble can.